Thanks, Alex. My name is Robert, and as was introduced, I'm the CEO of Vultus, and our mission here is to eliminate waste in farming. But this presentation isn't really that much about what we do, but I'll give a little bit of an introduction to us, and then I'll go through more in our view, sort of what are the key challenges that we see in agriculture and some really large opportunities that we see ahead for the space. So just shortly about kind of what we do. So we provide precise satellite recommendations that are integrated with existing machinery and that help basically farmers to use their inputs more efficiently. So you can save quite significantly on some of your key inputs, such as nitrogen, fungicides, and irrigation. And this means you can produce more food using less chemicals, which is very important for many reasons, but margins and yields are probably for the grower the most important thing. But also for us, I think making farming sustainable is what we're really passionate about. In terms of how this works, so we measure different things about the fields using both optical and microwave data. And we measure things like moisture in the soil, nitrogen uptake in the plant, soil organic carbon, and so forth. And these measurements are then put into different types of geospatial models and different types of other models that are basically producing recommendations of where you need to apply more or less of the specific inputs. And these are implemented directly into the machinery. So as the farmer is driving across the field, it varies the output based on the positioning, because almost all the hardware or the tractors and so forth have positioning hardware. So it just varies the dosage based on the positioning, and therefore you get the correct dosage at the right place. I mean, a little bit about where we are right now. So we were founded in 2016. We're still sort of quite early stage, but we have a team of about 20 people. We have about 500,000 hectares using our services. So it's about 7,000 fields. And it's a number that's growing quite rapidly. But yeah, so I'll end my part about us specifically there and kind of carry it over a little bit more into sort of the industry that we're working with and what are the challenges that we see in this industry and the opportunities that come with that. I think agriculture is clearly one of the larger industries out there, but it is also one of the least digitized, and there's a lot of opportunities to work with that digitization. And I think that's kind of where I would like to shift our attention. So agriculture is a really big and old industry. So I mean, it's been around for a long time, obviously. It surprisingly is really, really big. I mean, it's $2.4 trillion worldwide. It's about 1.1 billion people working in agriculture. So that's almost a third of all global employment is just agriculture. So it's very interesting how intense it is in terms of manual labor. The average age for a farmer is surprisingly high as well. So in the US, it's about 58. And so that's the average age. So it's a very, very old industry, and the demographics of this industry is very old. And I think this kind of unsurprisingly leads to some challenges in terms of digitization. So uptake of digital tools and software in agriculture is the lowest of all industries. So if you look at the bottom of this report, it's literally the least digitized. So it's one of the last industries to really be consumed by software. And I think this presents a pretty big opportunity to see, okay, what are the areas here where we can actually, in useful ways, deploy software to solve some challenges. And another reason why it's so little digitization is what is sort of the life of a farmer? The life of a farmer is really, to a large extent, it includes many things, but one of the really key components is risk. Because as a farmer, you have these massive upfront costs. So you have a bunch of equipment, land, inputs, labor that you need to put into running your farm. And then throughout, with the hopes of that you'll get that money back towards the end when you harvest. Now, during that entire period, you have massive sort of weather and production risks, because you can have a pest that decimates your crop. You can have different adverse weather events. I mean, there's a lot of different things that can go wrong. And even if everything goes well, I mean, then you can unfortunately get really have a really bad outcome if the markets are not in your favor. So if your crop that you're producing drops in price, which it does, it moves very sporadically, then you'll be left with losing a lot of money. So these are really a lot of different risks that the farmers have to deal with, and because of this, it makes them very focused on mitigating and reducing the risks that they're taking on. And unfortunately, because of this older demographic partially, and this focus on not having risks, technology is sometimes seen as a risk. So it's seen as, okay, I'm trying a new tool, I'm trying a new technology. And I think that's something which is very difficult to overcome, and something which is also why technology has taken so long time to get adopted in this space. And I think it's really important to see how can we actually change that mindset and actually reduce risk with technology, because I think that's definitely possible, and there's many ways to do that. Now, in terms of the challenges in the space and kind of what this leads to in terms of negative or like problems, I mean, one of the really big problems that we see and that we're working with is just the overuse of chemical inputs. So the way we've basically sustained food production and increased food production in the last 50 years or so has been just applying more chemical inputs. So you apply more fertilizers, you apply more pesticides, you use more irrigation water, more seeds. So all these things are oftentimes bad for the environment. And the way we use these inputs are really suboptimal in many ways. So unfortunately, you spread all the inputs evenly across the field. Basically, regardless of how your field varies, just spread it evenly, even if you know that there's massive variation. And you basically guess how much you're going to spread. So almost all the farmers have really crude ways of deciding how much they're going to spread, when they're going to spread it. It's just based on kind of gut feeling and what you did before, or that's the case for the vast majority of growers out there. And this leads to a lot of input waste. So nitrogen, which is the biggest fertilizer by far, there around 55% goes to waste. And you have similar waste profiles for most of the other inputs as well. And this leads to a lot of problems for the grower, because there's a lot of costs associated with this and for the environment. I think one of the reasons why you have this problem, and another kind of really systemic problem, is the lack of really digital data. And I think this is one area where I think remote sensing can help a lot, and especially GIS data. I mean, right now, how you're collecting data is unfortunately that you go out into the field, you scout usually manually, and you collect this analog data. I mean, it's just sort of you build your own feeling about what's happening in the fields. You usually don't, in a standardized way, collect this data and document it. And this leads to a lot of production risks, because you don't actually know what's going on in your different fields. You can't really track your performance that well and see what leads to what. And this sort of lack of digital data is really widespread across the sector. I think there's a lot of efforts to improve this, but it's still really a bad situation there. In terms of sustainability, I mean, agriculture is clearly, there's a lot of sustainability aspects to this, and it is a really big challenge that we need to improve food production. We need to increase food production by around 70% by 2050. Meanwhile, we need to actually, reduce the emissions, and so we need to reduce emissions from farming, the land use from farming, and increase food production massively, which we've previously only done by applying more inputs. So it's kind of a difficult thing where you can actually how to balance this and how to get that efficiency improvement. So I think there's a lot of challenges here, how we do that and how we balance it with things like food quality and water quality, which are also really key considerations. In terms of the infrastructure, I think it's very interesting that in this sector there's really a widespread lack of standards and a widespread sort of compatibility issues where different things just don't work with each other. And I think this stems from there's sort of a lack of experience with technology in this space, especially if you look back in time, and a lack to some extent of talent in this space. I mean, today, even the most of the more modern farms, most of their maps are actually paper maps. Like the experts that give you these maps, they give you it on paper, and you would think, in many sectors that would be not the best idea, but that's because you have these different standards, you have different ways of working with different tools. There's really a lack of infrastructure that works, and this is causing a lot of issues. I'd say a really interesting example of this is if you have, for example, if you look at data ownership. So if you have a combine harvester and you're harvesting your field, in many cases, the farmer actually doesn't own the vehicle data. So it doesn't own the data about how much harvest was produced because it's counted as vehicle data that in many cases is owned by the vehicle manufacturer, or the OEM. And so But even if you did own that data, what do you do with it? If you can't actually transfer this data into the different digital platforms that you want to use, because everyone is following different standards, well, then you can't actually utilize the data. You can't actually store it. You can't actually collect the same data and compare it across different farms. And this is creating, huge issues. I mean, it's leading to this lack of digitization and adoption of these tools, because the infrastructure, even if it's improving, even if there's a lot of efforts going on to improve this space, it is still, comparatively weak. There's a lot of work here that needs to be done to make this standardized and make it sufficient or sufficiently good for many of these use cases. Now, I think kind of shifting the focus, like having these big problems really creates a lot of big opportunities. So, if you want to, work on something that has to be both a really big commercial market, there's a lot of really underserved communities and huge needs, and you can have a big impact. I think this is really a good space to be in many of those ways. And so one of the I think, really massive opportunities is that needs to be solved, I think, first is really building key infrastructure in the space. I think we need to have more standards for, how different data is compatible with each other, like how data ownership is handled. We need someone to build sort of, Android for farming, or like some sort of operating system or something like that can make everything tied together, make all these fragmented systems, be useful with each other. Another, I think, the thing that we're working on and where I think there's a just massive opportunity is solving sort of the input crisis and solving how we're using inputs. So we need more data about where different inputs are needed, and we need to know. We need to have sort of recommendations for where you should apply more inputs, where you should apply less inputs, when you should apply these inputs. This is just a massive opportunity to solve really a lot of economic issues and a lot of environmental issues. And I think here geospatial data is key. So you need to be able to measure, where do you need, for example, your fertilizer, where do you need your different pesticides, when do you need it, and then to give those recommendations in an easy way to the farmer so that they can actually take a better decision there. I think there's just a lot of things happening in this space, and I think this is really going to be growing significantly towards the future, is sort of solving the climate crisis from the agricultural side. I think we need to, we clearly need to reduce the emissions from farming, but we need to also reverse land use trends, because what's happening across the world is that more and more land is being used for farming, and how do you get more land? Well, oftentimes you cut down forests or you burn forests, and that's clearly not sustainable, not something we want. And I think to reverse the land use trends, we need to improve efficiency. We need to really find ways to produce more food or use less food, and therefore be able to restore the forests. And then another, I think, really interesting part is, can we store carbon in soils and through farming? There's a lot of initiatives right now to see if we can reverse climate change with farming, and have farming practices that make the carbon get more and more stored in the soil. I think geospatial technologies is really a key part of all those solutions, and I think that's something which it has a lot of potential, and there's a lot of money going towards. I think the last point I'll touch upon is that really we need to empower the farmer with geospatial technologies and solve a lot of these problems. We need to solve the problems of waste. We need to solve the problems of risk. Clearly, if you have a lot of data about what's going on, you understand how things vary and what impacts, what has what impact, and you have all these different types of data and measurements, you can clearly reduce the risk in growing. You can make farming more predictable, and you can make farming more profitable. And I think this is something which is really, it begs for more technologies, especially on the geospatial side, that can solve all these things. And I think it's something which I encourage, if you're looking for something to do that, where there are these underserved communities and where, you can have a big impact both from a sustainability perspective, but also the commercial side, then I would say, work in farming. And I think that's why we're so passionate about it, and why we see it as really the core mission of what we're doing is to reduce waste in farming. And I hope hopefully more people will be working towards that, so we can together make farming sustainable, because it needs to happen, and the faster we do it, the better. With that, I'll end my part. Thank you.